Welcome, Hornets. Thank you for joining me today. Today we're going to be taking a look at a warm-up that involves working with our derivatives and a chart, be it an inverse or be it the chain rule. We also have a question that involves the critical values of a function x to the 2/3 power on the open interval from -2 to 3. So I'd like to begin with our first question. Find h of x equaling the cubed root of g of x when h prime equals 0. So we have this function, we are working with that derivative, and we have to work with the chart. Notice that h is not something on the chart, which forces us to work with g. So we're going to have to first figure out what is h prime without the 0 in it. So we're going to find h prime of x. Now, in order to do this, we need to first change our h of x into a rational exponent. So we're going to have to change it into 1/3, so g of x to the 1/3 power. This will give us 1/3 g of x to the -2/3 power times g prime of x. We can now plug in the 0 and find what is g of 0. G of 0 is 1, so we're looking at 1/3 times 1 to the -2/3 power times g prime at 1, which is 5. Since we know that the square of 1 is 1 and the cubed root of 1 is 1, whether it is in the numerator or the denominator, it will not change the outcome. As a result, our answer can only be 5/3. And there we have our derivative of h prime. We then go to h is the inverse of f. Once again, h is not given to us in the chart, so we have to work with the f. Now we know that h prime of some value, in this case 4, has to be 1 over the inverse derivative at the corresponding y value for that h. So we have to think about it in terms of the f. And if we're looking at f, 4 is the outcome. It is the y value. So we need to look along f and locate where we have a 4. You'll notice this is going to give us a 2. And therefore we know that the point for f was 2, 4, and for h, that equation would have 4, 2. So I'm now going to find my derivative of f at 2, and that gives me a 3. So I have a slope of 1/3. I also know that h of 4 is equal to 2, and this now gives me my point and my slope. I can now write the tangent line. H of x minus my y value 2 has to equal my slope times x minus the given value 4. This is now the equation of the tangent line that we seek. Now, in number 3, we're no longer using the chart. This is now working with our function x to the 2/3 power. So I need to first figure out what is my derivative. F prime of x is equal to 2/3 x to the -1/3 power. That's going to give me f prime of x is equal to 2 over 3 times the cubed root of x. And we're asking ourselves, when is the function going to be equal to 0? And we can see that our numerator is a 2, and 2 cannot be changed. So f prime of x cannot be 0. We then go to the second part of that, which is, when is f prime undefined? F of x is undefined at x equals 0. Notice that the cubed root of 0 is 0. 0 times 3 is 0. And that will give me an undefined value. Since x is undefined, I'm now writing a sentence. Since x is undefined at x equals 0, the critical value of f of x is x equals 0. Now at this point, I could make a table of values and figure out, well, I know that I have an increasing function and then a decreasing function on the negative side, yet an increasing function on the positive side. Now, if I were to make my table of values to try to graph this, now I'm not asked to, but I want you to think about how we would graph. We know that 0 is where there's a problem, so I only want to use perfect cubes. Negative 1, let's use negative 8 and negative 27. I end up getting a negative 3 for my y. Let's see, let's try that again. Negative 2/9. This is going to give me negative 1/3. And then I have negative 2/3. On the opposite side, I'm going to have positive values. Once again, we're talking about y prime here. And I'm just plugging in these values into my table of values. And I can clearly see that I am looking at 2/3 on this side, 1/3, and 2/9. So I can clearly see that on this side of the undefined derivative, I have negative, and therefore my function will be decreasing. And on the positive side, I can see that it's going to be increasing. So, from this, I can now start to view the graph as doing something like this, where there's a point of inflection. Now, the next step would be make a table of values and work instead of x and y prime, I would start working with x and y. And this would then give me values that I could then calculate. And from those values, I would be able to find what the graph would look like. And I suspect it's going to look something like this. Notice that the slopes are slowly decreasing or slowly increasing negatively, just as we have here, and then decreasing positively, as I have here. Alrighty, so a quick look at our graph would determine whether this is accurate or not, and I recommend that you take a look at your graph and see if we've come up with something that looks similar to what the graph would normally look like. This is the whole idea of working with critical values and our ideas of the first derivative test, which we will be talking about in the future. Thank you very much, Hornets. I hope this has helped. This was our warm-up for today for those of you who want to see it again. Thank you very much and have a wonderful afternoon. Cheers. Take care. Be well. Bye-bye now.